Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Mr. Chika welcoming you to today's session. In today's session, we are going to be covering lesson 1.3, Vectors and Dot Products. Today's session is part 1 of the series, and this video is exclusively made for grade 11 elite math students who are going to term 1, and learning objectives of the session are to find the dot product of two vectors and use the dot product to find the angle between the vectors, and secondly to solve some textbook problems on dot product and finding angles. So today's session pretty useful for all grade 11 elite students, and towards the end of the session you'll have some important textbook problems, so watch the video till the end so that you don't miss on the important questions. If you are given two vectors u and v, with the first vector u having the components u1, u2, that is the x component. As you all know, the first component represents x, the second component represents y. So this is the horizontal component, this is the vertical component. Similarly, in vector form, the second vector v has v1 as the x component, v2 as the y component. Then u dot v. So it is denoted by this value. This is how you write the dot product. And this dot product of the two vectors is a number. It's a scalar. So it's not a vector result. The result that you're going to get will be some number. So it will not have any direction, just the magnitude. So not a vector. This is very important. That's why it is called dot product, or you will also have another name for the same thing called scalar product. So it is called scalar product because the result is a scalar quantity. It is not a vector. Okay, so this is one reason that will help you remember. And again here, like your components, you will take the u1, the x component of the first vector, with v1, the x component of the second vector, multiply and then add the result to u2 times v2. So u1 v1 plus u2 v2, that's your result of dot product. Let's take a simple example and learn how to find the dot product. So here I have with you two vectors. The first vector has x component 4, the y component minus 6. The second vector has first component x 2 and y minus 2. So we have to do the dot product. That means we have to multiply component y. So 4 will be multiplied with 2, minus 6 will be multiplied with minus 3. So 4 times 2 is 8, minus 6 multiplied with minus 3 is 18. Now the negative and negative cancels, becomes positive in multiplication. So be careful about the sign, and eventually you add 8 with 18. So that gives you 26 as the answer. So our result for the dot product for this question is 26. So let's take a textbook example. Here you are given the two vectors. I am taking it from your math book, Guided Practice 1A. So two vectors, x component 3, y component minus 2, second vector x component minus 5, y component 1. You have to first find the dot product and then check whether these vectors are orthogonal or not. So let's find the dot product, u dot v. So u dot v means we are taking the dot product. So 3 will be multiplied with minus 5 and minus 2 will be multiplied with 1. So let's see the result. Minus 15 minus 2, so it is minus 17. That means it is not 0. So if the dot product is not equal to 0, we can say the vectors are not orthogonal. So u and v vectors are not orthogonal. That's the condition you had to check. Let's do 1b also. I'm going to change the color. So u dot v here becomes minus 2 times 9 plus minus 3 times minus 6. So what is this? Let's multiply minus 18. Now negative 3 and negative 6 when multiplied becomes positive 18. So this is 0, and if you have the dot product of two vectors equal to 0, means those two vectors are orthogonal. So here you can see in 1a you got not orthogonal, whereas in 1b you got orthogonal vectors. So just look at the dot product. The condition is this: if the dot product is 0, they are orthogonal, otherwise not. Let's look at some properties of the dot product. These are very simple properties, some of which you already know. The first property says u dot v is equal to v dot u. What is the name of the property? Here the order is changed, but the result is same. So this is called commutative property of the dot product. So if you change the order, the result of the dot product does not change. That's the first property. Second one, where you have a zero vector, so this is called zero vector dot product property. So zero vector multiplied with any vector would obviously give you zero. So the zero vector, why zero vector? Because one vector is zero. So zero vector dot product property. This is the second one. Very easy to remember. Next one, here you are going to do the distributive. As you see, you have 1, 2, 3, 3 vectors. So you are distributing u vector over v plus w. So when you distribute, this property is called distributive property of the dot product. Next one, where you take the dot product of the same vector. So v dot product with itself is equal to the vector magnitude. So this is called dot product and vector magnitude relationship. So dot product or vector magnitude. Why vector magnitude? Because here I have taken the magnitude of the vector v and taken its square. So dot product or vector magnitude property or relationship. So just you can remember them by looking at their values. So v dot v, definitely it is the vector product, sorry, it is the dot product of the same vector, so it will be equal to magnitude. Here everywhere c is a scalar. Scalar means it's just a number. So if you multiply a scalar with the dot product, then it will be scalar times the first vector times dot product, or first vector times scalar dot product. So C is like a number here. Okay, 5, 10, 15, anything. So here these are the 5 properties of dot product. Now that you've understood about the dot product, let's have a look at its application. So in this slide, you are going to be learning how to find the angle between two vectors. So if you have two vectors like this given to you, vector v and vector w, and you need to find the angle between them, then there are some steps you are going to be following and a formula that you'll be using. So number one, you will take the dot product of the two vectors given to you. Then you will find their magnitude. So you will find the magnitude of vector v and the magnitude of vector w, both the vectors which are given. Then you will apply the formula which I am just about to show it to you, and then in the end, because you are going to find the angle, we are going to use inverse trigonometry. So you are going to take the inverse of cosine of the angle. So we are going to use the cos formula here in step 3 to get the cos theta, and then in the last step to get angle theta, you are going to take the use of inverse trigonometry and take the inverse of cos. So let's have an example on the next slide along with the formula. Okay, so this is the formula I was talking about. Let's make it an important one. So cos of theta is in the numerator the dot product u dot v of the two vectors given to you in the question divided by their magnitudes, the product of their magnitude. So if the vector u and v are given to you, the two vectors, you can easily find the dot product by what you've learned till now, and then divide by their magnitude. Use the magnitude formula here to calculate both of them. And once you get a number here, the next step to get the angle theta or the angle between the two vectors would be to take its inverse. So in a way, theta is cos inverse last step u dot v over magnitude of u multiplied by magnitude of v. So this is the final formula. Okay, so let's take an example. In this example, you have to find the angle between the vectors u and v. They are given to you. So we are going to follow the 4 steps you saw. So first you'll do the dot product, then you'll find magnitude of u, magnitude of v, then you'll apply this formula cos theta, and last step you take the inverse of cos. So this is how the dot product is going to look like. I hope you remember that you take the dot product of x with x and y with y. So 1 multiplied with 3 plus minus 5 multiplied with minus 2. You simplify, you get 13 as the numerator. For denominator, you are calculating the magnitude of the vectors. So this is magnitude of vector u and this is magnitude of vector v. So you use the magnitude formula. That means you take the x component, square it, y component, square it, and then add it up. So how much is this going to be? 1 plus 25, so square root 26. That's the magnitude of the first vector. For the second vector, it is magnitude of 3 square plus minus 2 square. So this is 9 plus 4. That would be square root 13. Now that you've got all the things, the product, the dot product, the magnitude, you'll use this formula, plug in everything here, simplify, and let's see what we get. Okay, so we got our u, we got our dot product, we got magnitudes, we put in there here, we substitute the values, square root 3 cancels and you get this as the value. Convert to decimal using your calculator, it comes out to be 0.7071, and last step to get angle theta is to take cos inverse, so the angle comes out to be 45 degrees. So the angle between the given two vectors u and v in the question is 45 degrees, and the formula that we have used, I want you to learn this, it's an important one, is this one. So that completes the question. Okay, so I want to talk here a little bit about parallel and perpendicular vectors. This is pretty important. So as you know, the formula for finding the angle in terms of cos of the angle, cos of theta or cos of alpha is this one. Now think a little bit what would happen and what would it mean if this resulted in a value of 0. Means if the angle comes out to be 0. So if angle is 0 means your alpha or your theta is 0. Then cos of 0 degree would be 1. Okay, so this result would come out to be 1. So if the angle is 0 means they are, if the angle between them is 0 means they are parallel vectors, right? So that will be this case. And what about, what do you think if the, what angle has a cosine of 0? Just think about this question. So if this result comes out to be 0, that means your theta would be 90 degree. Why? Because cos of 90 is 0. So if this whole result is 0 means the angle is 90. So the given vectors are perpendicular. So the vectors are at 90 degrees to each other. So they are going to be perpendicular vectors. Such vectors are also called orthogonal vectors, as you saw towards the beginning of the session when we solved the problem on orthogonal vectors and calculated the dot product. So as I promised you, towards the end of the session, we are going to do important textbook problems. So here I am with 4 important questions of guided practice from your math book. Out of these, we are going to try question number 17 and 19. These are like your classwork that we'll cover in the video. I would really want you to do 16 and 18 yourself. That's your homework. You are going to solve it in your notebook stepwise in the same way that we are going to solve question 17 and 19. So let's find the angle between the vectors u and v, and remember to round it off to the nearest tenth of a degree. So 1 decimal place we are going to round off. You are going to use your calculator here because we are going to do arc of cosine, or we are going to use inverse trigonometry. So remember, cos of theta is equal to u dot v in the numerator divided by the magnitude of u multiplied with magnitude of v. So we are going to do stepwise. We'll first calculate the dot product, then we'll do the magnitude, divide them, get a number here, and in the last step use inverse trigonometry. So let's go on to the next slide and do 17 and 19. Stay glued and let's solve it together. Okay, so let's do the first question, 17. Here, let's first do the step 1. So I'm going to write the steps one by one. Step 2, step 3, there are 4 steps, and step 4. So step 1 is to calculate dot product of u and v. That means u dot v. So here it means you will take the x with x, y with y. So 7 with 4 plus 10 with minus 4. So how much is this? 7 multiplied with 4 is 28. There is a negative sign, negative of 40. So now you just subtract them both and you get negative 12. So you've got the numerator. Let's change color and do step 2 where you need magnitude of u and magnitude of v. So we are going to use magnitude formula 7 and 4, so squares. Similarly here 10 and minus 4, so 10 square plus minus 4 square. Okay, let's simplify it a little bit more. So this is 49 plus 16. This is 100 plus 16. So what is this? In square root, finally we get, let's add them up. 49 plus 16, that's 65 in square root, and this is 116. Okay, so we got the magnitude. Step 3, we will use the angle formula. So cos theta is u dot v divided by magnitude u magnitude v. So just plug in. So dot product in the numerator from step 1 is this. In the denominator, it is this. So this can be written as, let's simplify it a little bit, square root of 65 multiplied with 116. This is 7540. Now we are going to simplify it and put it in decimal form. So let's first calculate the square root. Okay, so the square root of 7540, the denominator, is negative 12 here, 86.83. Now we are going to divide. So when we divide, this comes out to be 12 divided by 86.83. So this is around negative 0.138. Okay, last step would be to take the inverse. So this is cos inverse of negative 0.138. So let's take the inverse and get what we get. So use your calculator, use the inverse function to get the angle, and when you see, this comes out to be 100 degrees. So that's your answer. So remember the steps that we are following, step 1, 2, 3 and 4. So first you do the dot product, then you calculate magnitudes, then you put it in this formula for the angle, and then you take inverse of the angle. So get your answer. Let's do one more question to make you more comfortable. We are going to follow the same steps, step 1, step 2, step 3 and step 4. So let's do it one by one. We are going to change the color now. So first step, you take u dot v, that is the dot product. So here we have, see how we can write this in the form of vector minus 2 comma 3, and this is minus 4 comma minus 2. So now it simplifies, negative 2 with negative 4 plus 3 with minus 2. That's your dot product. So 8 minus 6, which is 2. Now you take the magnitude of u and magnitude of v. So very easy, minus 2 square plus 3 square coming from here, and from here you have negative 4 square plus negative 2 square. So this comes out to be 4 plus 9. This comes out to be 16 plus 4. So this is square root 20 and this is square root 13. Okay, now we do it in the formula. So u dot v divided by magnitude u magnitude v. So the numerator is 2, denominator is this. Now we can just simplify it a little bit more. Let's take it inside. So this is square root of 260. Now we need to convert to decimal. The square root of 260 would come out to be almost 2 divided by 16.12. So now you divide, so it's near about on division, giving you 2 divided by 16.12, which is 0.1240. So now last step is to take cos inverse of this number, and it will come out to be 82.9 degrees. So I hope you have now been more comfortable in finding the angle. These are the major steps that you should be following. Learn this formula, it's very important, and then use your calculator to get the final step. So that brings us to the end of today's session. We have completed part 1 of lesson 1.3, vectors and dot products. If you like the video, do give it a thumbs up, share with your friends who will benefit from this video, and don't forget to subscribe to the channel if you haven't till now. Also press the bell icon so that you receive all my upcoming videos notification. And remember, coming up next is lesson 1.3 part 2 of today's lesson. So we are going to finish it up in the next video. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.